Right boys, so I'm going to kick off your second lesson on accuracy and bounds with a bit of another explanation on working out error interval. Some of you have done really well on this, some of you have got the wrong end of the stick a little bit. So I'm going to show you how to do these the same way that you might have watched yesterday, and then I'm going to show you a different way which I think you'll find easier but doesn't necessarily help you understand it. The method you watched on the video yesterday and that I'm going to show you at the start of today is really the one that helps you understand. The second method makes it easy to do the questions, but I don't think you'll necessarily understand it all. Understand the whole idea very well. Anyway, let's go through them anyway. So the first one, we got 5.7 to 1 decimal place. Says for the numbers below, write down the associated error in. So we got 5.7 to 1 decimal place. What you'd have seen yesterday is somebody draw a number line and write 5.7 in the middle of it. Then they'd have gone to the next number along the number line with 1 decimal place increasing. That will be 5.8. 1 decimal place is a bit like 0.1, you see. So we've gone 0.1 above, then 0.1 below. And then on the video the person would have said that anything between these two lines here, okay, would get rounded to 5.7 to 1 decimal place. Anything in this zone here would get rounded to 5.6. Okay, if I put an arrow here, that there points to a part of the number line that's nearer to 5.6 than it is 5.7. Okay, so whatever number that is, about 5.64, that's going to round to that number, not 5.7. So this is the lower bound here, this is the upper bound here. Okay, 5.65, and the upper bound is 5.7. Okay, and right between them is something like this. I'm going to use the letter X to go between them. The lower bound always has an or equal to, and the upper bound doesn't. And I think you picked up on that because that's the same for every single question. Here's the alternative way of doing it. Okay, if it's been rounded to 1 decimal place, if you can convert 1 decimal place to 0.1, okay, then it's quite easy to answer this question. What you do is you half this number, and you get 0.05. Okay, and then the lower bound is this number here on the left. The lower bound is the original number, take away 0.05. So 5.7 minus 0.0. And the upper bound is 5.7 plus 0.05. Okay? And hopefully you can see there, look, you're going to get 5.65, the same as we had here. And here, look, you're going to get 5.75. So you end up writing the same pair of answers, doing it that way. Okay, I'm going to do this one, the second one by that method. You've got 6.34 and it's been rounded up to 2 decimal places. Okay, 2 decimal places, okay, is rounding up to the nearest one of these, if you like. We half that number, we get 0.005. Okay, so what I'm going to do is take that away from this number to get the lower bound and add that on to this number to get the upper bound. And the adding on one is going to be really easy. Take that number, stick that 5 on the end. Okay, so I'm kind of dodging this by doing the upper bound first. When you take that number away from this, you get 6.335. Okay, right, and the easy way of checking these answers is to look at the two numbers, look at how far apart they are. They should be that far apart, 0.01 apart, and you can hopefully see that they are 0.01 apart because the only difference, that number there and that number there, 0.01 away from each. Same idea again, it's really easy here. We're doing it to the nearest 10, so we're going to half that number and we get 5. We take 80, we add 5 on for the upper bound, and we take 5 away for the lower bound. Okay, and we get that to there. Now I'm just considering showing you question 7 again very quickly before we do anything else. Paper. Oh, let's do this. So question 7 yesterday caused quite a few of you a problem. That's here. Get the answers there, but let's not worry about that. 10.300 to 3 decimal. 10.300, 3 decimal places. So 3 decimal places will be 0.001. Okay, half of that is 0.0005. So for the upper bound, I'm going to do 10.300 plus this number. That. And then for the lower bound, it's 10.300 minus this number. This is where a number of you went wrong. I'm probably going to go wrong as well. I think it's that. Yeah, I think it's that. Yes, it is. If I added on 0.001 to this number, I would get that number, wouldn't I? Show you that underneath. 0.01. Whoops, I lined that up very well. Have I? Try that again. Sorry about that. Better. Let's see. 5 plus blank is 5. 9 plus 1 is 0. 1. Carry the 1. 9. 1 makes 10. 0 carry. 2 0 and 1 makes 3. Then the dot. Then 0. Then yes, we've got that number. That is the answer. So that idea of writing down the number which you sort of rounding to 3 decimal places means 0.001. Halving it. And then adding and subtracting it from this. You know, it's a sort of bit of a trick really, but might help some of you who struggled a bit yesterday. Okay, so we're going to build on that idea now with a slight development. Okay, this is the style of question I want us to practicing most today. Okay, let's read it. I've called it development question. It's just like the next step for X and Y have been rounded to 1 decimal place. X is 3.7, Y is 52. Work out the lower bound and upper bound for X add Y, X Y, which means X times Y, and X over Y. Okay, to answer this question, okay, we need to work out the lower and the upper bounds for these two numbers. Okay, I'm just going to see if I can, just going to go get another colour so you can see my working clearly. Okay, I'm back. So, let's look at 3.7. That's been rounded to the 1 decimal place. 1 decimal place means 0.1. If we half that number, we get 0.05. So, the lower and upper bounds are going to be 3.75 for the upper bound. Whoops, don't want that there, I want it there, don't I? And the lower bound will be 3.65. Using the idea we did a minute ago, it's 3.7 minus that. And it's the same deal with the Y because it's been rounded in the same way. The upper bound is 52 plus 0.05. That's 52.05. Okay, and the lower bound is 52, take away 0.05. It's 51.95. Okay, so now I've got the upper and the lower bounds for each number. Okay, now then, 2 of these questions are nice and straightforward and really simple, and one of them is a bit different to the others, a bit of a twist. Okay, so I'm going to do part A first, and then I'm going to get you to think about whether B is going to be the same as A or different, or C is going to be same or similar to A or different. So let's look at A. We've got to do the lower and upper bound of X plus Y. Well, the lower bound, and I'm just going to write LB, the lower bound, is, we need to be adding them together, and we're going to be choosing one of these bounds for X and choosing one of these bounds for Y. We want this overall to be the lowest it can possibly be. Well, the lowest it can possibly be is going to happen when we take the lowest X and the lowest Y. Okay, so you probably guessed that. 3.65 plus 51.95. Okay, I'm going to get a calculator rather than risk the mental arithmetic on that. 3.65 plus 51.95 is 55.6. So there's the lower bound and the upper bound. And unsurprisingly, you're going to add the two upper bounds together. 3.75 plus 52.05. Type that into the calculator. Typed it incorrectly. And there's the upper bound, 55.8. Okay, you will notice that they are 0.2 apart. They're not 0.1 apart, they're 0.2 apart, perhaps because you've added two things that have been rounded to 0.1. Anyway, there they are, and it would be a good idea to present the final answer as an error interval. You don't have to do this, but it's a good habit to be in. So there it is there. Okay, right. Hopefully you've had a think about whether this one's pretty much going to be the same as that, or this one's pretty much going to be the same as that, or conversely, which one's going to be a bit different. And the answer is C. Okay, I am not going to do B. I'm just going to talk you through it. You'd have to sort of follow the same idea as this. The only difference is, and you'll be using these numbers for the lower bound and these numbers for the upper bound. Instead of adding, you will be multiplying. Instead of writing x plus y here, you will write xy here. Okay? Now then, the reason why this is different is this, is because you're dividing. If you want the lower bound for x divided by y, the lowest number this can possibly be, okay, you want this to be as low as it can be, and this one to be as high as it can be. Okay, I'll just say that again. You want this one to be as low as it can be, and this one to be as high as it can be. That will give you the lowest possible value of x over y. If you're not sure about what I'm saying there, then perhaps what we should do is this. This would be a good investigation to do. For x, you're going to choose one of these two numbers, and for y, you're going to choose one of these two numbers. There are actually only 4 different divisions we could do. So I'm picking 3.65 for the top. So it's either that or that. That's 2 of them. And then there's the 2 divisions with 3.75 on the top. Because you have to pick numbers from this group of 4. You can't pick something else. So all of these are the only possibility for the lower bound of x and y. And if you're really thinking about it, one of these is the upper bound as well. And one way of approaching this is to write all of these down, work them all out, okay, on the calculator, and then just choose the lowest number as the lower bound and the highest number as the upper bound. I mean, that's fine, that will work, but it's best if you do understand that to get the lowest possible value out of this, out of a fraction, we want the top number to be as low as possible and the bottom number to be as high as possible. Dividing a low number by a high number can give you the smallest. So the lowest x can be is 3.65, the highest y can be is 52.05. So whatever number this is the lower bound. 3.65 divided by... That is a horrible, horrible number. But that, I'm afraid, is the bound. Now, strangely, feels like I'm going to be rounding up when I'm in a question about rounding. So I perhaps haven't written you a very good question here because this goes on for very many decimal places. I think the questions you will do, they won't be quite as long as this and be able to. Anyway, that's not too important in terms of your understanding. I've got the lower bound, I'm now going to get the upper bound. You are going to get the highest possible value out of this division. Choose the top to be as big as possible and the bottom to be as small as possible. Again, if you don't understand this, just write all these down and work them all out. The top to be as big as possible is 3.75. The bottom to be as small as possible is 51.95. So it's those two. In hindsight, I should have written y over x for this question, but it's too late now. There's not much higher, look, but that is a higher number than that one. And then you would write, I mean you can leave it like that, but it's a good idea to write the answer like this. Okay. And there's the final answer for the lower and upper bound. I've got the equal. Okay, sorry about that. That's better. That should be where the or equal goes. Not be there. Okay. So you've got to remember that the division one is a bit awkward. You've got to think more about whether to do the choose upper or lower bounds. The same would happen for subtraction, by the way. If I give you a question with subtraction, okay, if I want you to do x minus y and the lower bound of that, as low as that can be, you want that to be as low as it can be and that to be as high as it can to get an overall lower bound. And to get an overall upper bound, you want that to be as high as it can be and that to be as low as it can be. Alright, so subtraction and division, I mean, you know they're a bit more difficult than adding and multiplying, and that's certainly the case with bounds. I hope this helps. If you've got any questions, please get in touch with me on Teams, send me an email.